A lioness was chasing a warthog and finally caught the warthog, and now the two are sliding together in some direction. We're asked in this problem to figure out how fast the lion-warthog object is going and in what direction. To solve this problem, the main idea we'll use is conservation of momentum. We'll equate the momentum of the lion and warthog when they hadn't been entangled together to the final momentum of the lion and warthog when they're sort of stuck together. In this initial system, the lion and the warthog each have their own momentum, and we can write that as the mass of the warthog times the initial velocity of the warthog plus the mass of the lion times the velocity of the lion when it was initially just sliding. The momentum for this object here is then the mass of the warthog plus the mass of the lion, because we can treat this, the lion and warthog, as one object, times this velocity, which we're going to want to find. The first step we'll take is to find the initial momentum of the warthog and the lion before they collide. Because momentum is a vector, we're going to need to find both the x component and the y component. The x component of the initial momentum is equal to the mass of the warthog times the velocity of the warthog in the x direction, plus the mass of the lion times the velocity of the lion in the x direction. But remember from part A that the lion was moving in a purely vertical direction, so the x component of its velocity is 0. This means that the x component of the momentum is just equal to the mass of the warthog times the velocity of the warthog in the x direction. For the y component of the momentum, this is simply just the mass of the warthog times the velocity of the warthog in the y direction plus the mass of the lion times the velocity of the lion in the y direction. Now we'll apply conservation of momentum to find the components of the velocity of the entangled warthog and lion. For the x component, we have on the left-hand side the x component of the initial momentum, and on the right-hand side we have the x component of the final momentum of the entangled warthog and lion. We want to solve for this x component of Vf, and we do so by dividing both sides by mass of the warthog plus mass of the lion. We substitute in the values using what we found in part A to find that the x component of the velocity of the entangled warthog and lion is 2.8 meters per second. We do the same thing for the y component. On the left-hand side, we have the y component of the initial momentum, and on the right-hand side, we have the y component of the mass of the warthog and lion entanglement. To solve for the y component of the velocity, we divide both sides by the mass of the warthog plus the mass of the lion, substitute in the values found in the problem statement and in part A, and evaluate to find that the y component of the velocity of the entangled warthog and lion is 11.8 meters per second. To finish the problem, we use the components that we just found to determine the speed and the direction in which the entangled lion and warthog are traveling. To find the speed, we use the Pythagorean theorem and take the square root of the square of the x component of the velocity plus the square of the y component of the velocity, and evaluate to find that the speed is 12.2 meters per second. To find the direction of travel, we take the inverse tangent of the y component of the velocity divided by the x component of the velocity, substitute in values, and evaluate to find that the warthog and the lion are traveling in a direction of 76.7 degrees.